Hey guys, this video is about chemical changes and chemical reactions. It's a very important part of chemistry, so let's take a look. Alright, first off, like physical properties, there's also chemical properties. Chemical properties basically um, relates to a substance's ability to undergo changes that transform it into different substances. So you're going to ordinarily start out with a reactant and you're going to end up getting a product. Okay? And a chemical property describes that. So it's used to identify when a chemical change is taking place, okay, and new substances are formed. That's the key. New substances are formed. Now let's look at some words that signify a chemical change. All right. We have burn, decompose, which means to break down. Rust or oxidize means where oxygen bonds to a metal. Ferment is where yeast digest sugar to form alcohol. Explode, corrode, and react. And there's a little asterisk here. React is a very important one. Okay. Now let's look at a chemical change. What is a chemical change? It's a change that produces matter with different composition than the original matter. Okay, so we have three things here. We have an egg, popcorn, and fireworks. An egg, as you know, when you crack an egg open, it's clear and you have your nucleus there, which is yellow. Now this egg is cooking, okay? The clear part is turning white, so that's a chemical change. In the end, you cannot make this white protein portion go back to clear. Now over here, popcorn, you have the corn kernels, which where there is heat applied to it, popped into the puffy popcorn. You cannot reverse change this. You cannot go backwards to get the corn kernel. Fireworks, there's light emission. So the substance that exploded emitted this light, and you cannot capture the gases and the metals and put them back into the substance they originally were. Okay, so these are non-reversible. All right, so new substances form and they're irreversible. Okay, let's take sugar, decomposition of sugar. Now this could be done a few different ways. You can add sulfuric acid, you can heat it. So what happens to sugar is we have C12H22O11. You heat it up, or you can add sulfuric acid. It breaks down into three other elements. So this one molecule forms 1, 2, 3 elements. Okay, it's broken down. Each one of these has a different composition. Now, carbon is the black stuff left over when you burn something. Oxygen is liberated as a gas, and hydrogen is liberated as a gas. You cannot see these two leave, but they are there when they leave. Okay, they leave up in the smoke. Now, reactants and products are two of the main parts of a chemical change. Reactants are the starting substances in a chemical change. This is what you're going to mix together. They're reactants. Then together the reactants form something called a product, are the substances that are formed in a chemical change. So your reactants form your products. Now, there's a definition here. It's called the law of conservation of mass. Because we calculate the mass in chemistry, we weigh things, we can prove this definition. And it states that mass cannot be created or destroyed in ordinary chemical and physical changes. Okay, so mass is conserved. The mass is not going to decrease, the mass is not going to increase during a chemical change. You cannot make those elements disappear. You cannot make the compounds disappear. Okay, so whatever you put in the system to react, the mass is conserved and it stays. Okay, let's take this lab as an example here. We have 300.23 grams, okay? In an Erlenmeyer flask, we have sodium sulfate, and in a test tube, inside the flask, we have calcium chloride. Once you invert the flask, the calcium chloride pours out, forming a white solid. This is the new product, and it becomes empty. After the reaction, we notice it's the same mass. The mass is conserved. It stays the same. It does not increase. It does not decrease. That's because it's rubber stoppered. Nothing can get in, nothing can get out. Now, how do you know when to recognize a chemical change? Heat is produced. There's a change in color. There's production of gas bubbles. For example, if you have bicarbonate, which can break down to form water and CO2. Those CO2 form the bubbles. So if you see bubbles forming in a reaction, that's definitely going to be a chemical change. Not heating, water. Okay, that's a physical change. All right. In this case, when you have a decomposition reaction, bubbles form, then that's a chemical change. Okay. And lastly, formation of a precipitate, which is a solid or a cloud. And that's basically it. Just like the precipitate that forms, we go back a little bit here, right here, you have all these little white little dots that form. That's a precipitate, okay? And that's one of the 4 clues that the reaction is a chemical change, okay? And that's where we're going to stop.